Next, we're going to look at a very important characteristic of the normal distributions, the so-called 68, 95, 99.7% rule. To illustrate, I've drawn a normal curve, and I marked off the mean, and I marked off these intervals, 1 standard deviation to the right of the mean, 2 standard deviations to the right of the mean, 3 standard deviations to the right of the mean, and to the left of the mean, 1 standard deviation, 2 standard deviations, and 3 standard deviations. Okay, so I've basically broken up the area under the normal curve into 8 little chunks. Now the area under the curve is 1, or 100%, but between these two boundaries, mu minus sigma and mu plus sigma, you'll find 68% of all the area under the curve. And that's a general rule. That's where the 68 comes from in that rule up there. Okay, between mu minus 2 sigma and mu plus 2 sigma, that interval under the curve contains 95%, approximately 95% of the area under the curve. And if you go out one more standard deviation to the left or to the right, the area between those boundaries is about 99.7% of the area under the curve. And that leaves just a very small fraction of the total area for these small tails out here. Now this is something that is not exact. This is what we call a rule of thumb. And it's useful for estimating. It's useful for checking your work when you want to have a rough idea about whether your answers are reasonable or not. But if you want to do exact calculations, you're going to need a calculator or a table. And we'll look at how to do that later on. But this is useful for doing, back of the envelope kinds of calculations. Where you're just trying to make a rough estimate of things. And it's very useful for that. Okay, now what I've done on this picture is I've broken up those 8 areas and I put the percentages of the total area under the curve that's taken up by each of those 8 intervals. Okay, in the middle we have the 68%. Since this distribution is symmetric, each of these bands holds 34% of the total area. And out here between here and here we have 95%. Okay, well 95 minus 68 is 27, and if you divide 27 evenly in half, you get 13.5% and 13.5% for those areas. Out here in the tail, we have 99.7% of the total area under the curve between these two boundaries, and that leaves 0.3% for these two, which when you split it equally is 0.15%, and then that leaves 2.35% for each of these intervals right there. So this breaks up the area under the normal curve into 8 little packets, and you can answer questions about the behavior of a normal distribution by looking at these individually or perhaps grouping them together to describe particular proportions you might be interested in. For example, suppose we're interested in women's heights, okay, which are normally distributed approximately with a mean of 64.5 inches and a standard deviation of 2.5 inches. What I've done is here on my x-axis, remember I've defined x up there as women's heights, so it's okay to use an x down there. I put the mean in, 64.5, that's directly underneath the peak of the curve, and then I went 1 standard deviation to the right, 64.5 plus 2.5 is 67, plus 2.5 again is 69.5, and plus 2.5 again is 72. So I've marked off 1, 2, and 3 standard deviations to the right of the mean. Over here on the left, I went 1 standard deviation to the left and got to 62 inches. 1 more standard deviation takes me out to 59.5 inches, and 1 more standard deviation takes me out to 57 inches. Now we might be interested in asking questions. For instance, what proportion of all these women's heights are less than 67 inches? Well, we can answer that question. We know automatically the mean is at the 50th percentile. All these areas to the left add up to 50%, and we could just add that 50% to that 34%, and we would get 84% as the area to the left of 67, and that would be the proportion of all women's heights that are less than 67 inches. If you want to find the proportion that are greater than 67 inches, you could do it either way. You could add these up. They add up to 16%, or you could subtract that 84% from 1. And that's a very common thing to do when you're trying to find the area in the right tail of a normal curve, find the area to the left of the value you're interested in, and then subtract from 1. If you want to find the area to the left of 59.5, that would give you the proportion of women's heights that are less than 59.5 inches. Well, that's 2.5% right there. It's 2.35 plus 0.15% rather, 2.5%. If you want to find, say, the proportion of women's heights that are between 62 inches and 69.5 inches, you could just add up these three areas, 34% plus 34% plus 13.5%, and that would give you 81.5% for that area, and that would serve your purpose right there. That would give you the area of these three pieces combined. It would give you the proportion of heights, women's heights that are between 62 and 69.5 inches. Now you can use this in lots of other circumstances, and this rule generally applies. Now you got to remember that, again, this is a rule of thumb. It's approximate, but it's not exact, and if you want to do more exact calculations, you're going to need more exact methods, which we'll look at later.